Great. Well, hello, Torrance Public Library. I am so excited to be joining your event this morning. My name is Jessica, and I'm a volunteer for the NASA Solar System Ambassador Program. Some of you might be familiar with the program, but if you're not, the program works with volunteers across the country to share the latest science and discoveries from NASA's space exploration missions through community events. You can see some of the statistics up on the screen. Um, and as far as my background goes, I didn't study science. I studied marketing and communications. So I'm a talker. And I've always been interested in space. And in recent years, I started exploring more. I purchased some binoculars for stargazing, and I visited several of the space centers. And eventually I joined a local astronomy club and I applied to be a NASA Solar System ambassador because I wanted to continue learning with my neighbors and my community. And I wanted to inspire others to start looking up too, no matter how old they were, what their backgrounds were. This is actually my first year as an ambassador, and though I'm not necessarily going to talk about, how fast rockets fly or trajectories or even the engineering details about robotics, I am going to talk about things that I hope make you feel as curious as I do about space and space exploration. So I'm going to pique that curiosity today by talking about the Mars 2020 mission. I'm going to give an overview of NASA's Artemis program, and I'm going to look at how we'll use what we're learning to take the next giant leap in our space exploration journey. We all come into these discussions and talks at our own, levels. Some people have they've already explored on their own, and some people are here to start exploration. So I thought we would start with just refreshing a little bit of what we know about Mars. So the planet Mars is half the size of Earth, and it's a cold desert world. It's often called the red planet, which is a nickname it gets because of the rusty iron in the ground. It's the fourth planet from the sun, so its neighbors are Earth and Jupiter. It's a terrestrial planet, which means it has a compact rocky surface. It has an active atmosphere, but the surface of the planet itself is not active. Its volcanoes are dead. Mars has two moons. Their names are Phobos and Deimos. And Mars doesn't really sound like a place that I'd want to visit, but so why do we go there? Well, scientists want to know if Mars may have had living things in the past, and they want to know if Mars could support life now or in the future. So before I jump to the next slide, I want you to just take a moment to think about and guess to yourself, what year did we start exploring Mars? I'll give you just a second to get a year into your head. Well, NASA has been using robotic spacecraft to learn more about Mars since the 1960s, and that's when they sent a spacecraft to take close-up images of Mars. Then in the 70s, NASA landed its first spacecraft on the planet. And since then, several other spacecraft have orbited and others have landed on Mars. These missions all together provided some really early science data on the Martian surface. Interestingly, of course, Mars is the only planet that we have sent rovers to. So they drive around Mars, they take pictures, and they get measurements. They found evidence that water once flowed on Mars. And since living things need water to survive, finding the evidence that water exists or used to exist on Mars means that there could be or could have been life on the planet. So let's talk about some of the current missions. How are we exploring Mars today? So today there are 3 NASA spacecraft that are circling or orbiting Mars. The spacecraft are using scientific tools to measure volcanoes, canyons, craters, temperature, and the kinds of minerals that are on Mars. They're also taking pictures and searching for water. There's also rovers. They're exploring and mapping the different areas of the red planet's land. They travel around taking pictures. They look closely at the planet's soil and rocks. Some of the robots are landers, which means they just stay in one place. A lander might work on projects like measuring earthquakes on Mars or Marsquakes. And NASA uses pictures and information from the orbiting spacecraft, the rovers, and the landers to just continue to learn about the planet. The most recent mission is the Mars 2020 Perseverance Rover, which will be the star of today's presentation. So the mission overview, it was launched July 30th of 2020. It landed on Mars February of 2021. So it took about 7 months to get there. The key objectives are to seek signs of ancient life, particularly in special rocks that are known to preserve signs of life over time. The rover will be gathering rock and soil samples that could be returned to Earth by a future NASA mission. It does have a capability of sampling 30 samples. So that's a lot of scientific information. And it's also there to demonstrate technology for future robotic and human exploration. It will spend at least 1 Mars year, which is 2 Earth years, exploring the landing site region. So as I mentioned, the rover landed in February of this year. And the world watched live as that mission team attempted the most daring part of the mission, which was to land the rover on the surface. So there was the entry, the descent, and the landing, and this was live streamed worldwide. And my next slide is an overview and a reminder of the excitement that that we had during that time. This is going to be a video, and please let me know if there is any issue with the sound.
Propulsion, go. EDL phase lead, go.
We have deemed Perseverance ready to execute entry, descent, and landing on her own.
Confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second, about 120 kilometers from the surface of Mars. It will start controlling its path to the landing target. Parachute has deployed and we are seeing significant deceleration. The heat shield has been separated. Perseverance now has radar lock on the ground. The backshell has separated. Skycam maneuver has started, about 20 meters off the surface.
Tango Delta, nominal.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
So as you can see, this mission is important and inspirational worldwide. And I myself get a little emotional. I watched it live, and it was a really great day. So Perseverance's mission continues now that it is on the surface of the planet. So it continues to look for signs of life. But as some of you may know, Perseverance did not travel alone. So there was another robotic instrument that hitched a ride with the rover, and that was the Ingenuity helicopter. So the reason that the helicopter was sent was so that we could demonstrate powered flight on Mars and explore how future rovers and aerial explorers might work together. So a few things to know about this helicopter is that this is the first test of powered flight on another planet. It was built to be light and strong enough to stow away under the rover while on the way to Mars, and then to survive the harsh Martian environment after arriving on the surface. The helicopter weighs less than 4 pounds. It's powerful enough to lift off in the thin Mars atmosphere, which is less than 1% the density of Earth's. And the helicopter was designed to fly for up to 90 seconds to distances of almost 980 feet at a time, and about 10 to 15 feet from the ground. The helicopter flies on its own, so there's no human control. It has to take off, fly, and land with minimal commands from Earth, which are sent in advance. So now let's talk about what these two have been up to. One of the really famous photos that came from the mission, I'm not sure if you guys have seen it, but it was the rover selfie. Most of us know what a selfie is. It usually just requires a single person, but for Perseverance to take this selfie, the rover took 62 individual images, and those images were stitched together into a single selfie. And there's a really cool video that I'm going to share now that talks about how this process came together.
The way you and I might take a selfie is by holding a camera out with our arm and taking a single image. The way the rover takes a selfie is a little more complex than that. The way the rover takes a selfie is by using the Watson camera at the end of the robotic arm. But the Watson camera was designed to take close-up images of rocks for scientific analysis. And even with the arm fully extended, we can't cover the entire rover in a single image. To capture the entire rover, we take multiple images and then stitch them together. In order to do that, we try to hold the Watson camera sensor in the same position to take the different images. In order to keep the camera at the same position and take the different image frames, the arm may actually have to move quite a lot. It can take up to an hour of arm motion and imaging to take that entire selfie. The reason you don't see the robotic arm in the selfie is because it's moving between the different image frames that we are taking. And we include enough overlap between the images so that when we stitch them together, we don't have to include the arm. Another exciting first on the Perseverance mission is the inclusion of microphones. For the very first time, we were able to record sounds of the arm moving as it was taking the selfie. You can distinctly hear the sounds of the brakes on the arm actuators clicking open and closed. And at times, as the motors are changing speed, it almost sounds musical, like a flute. When a person takes a selfie, we just hold our arm up and take a single image. To create the first Perseverance selfie, it took an entire team of people working together for almost an entire week. In the end, it took 62 images stitched together to create the resulting selfie.
little more complicated than your day-to-day selfie, but really a really interesting process. So continuing with the mission update, I've pulled a couple of things that have happened recently. So there's the Mars solar conjunction. So NASA's Mars fleet is going to lie low because the sun will be between the Earth and the red planet. There is the Jezero crater's watery past. So there were some recent pictures that suggested the area's history experienced significant flooding events. Ingenuity recently completed its 13th flight, and it was able to snap multiple photographs during that trip. It was able to capture boulders, sand dunes, rocky outcrops. A few of the images, of course, capture Perseverance while it's out exploring. And then there were also rock samples that were analyzed for the sample collection, which again are going to help the team better understand a past that was marked by volcanic activity and water. So we're going to explore some more of these. I have some more videos for you guys. I hope that you're enjoying the videos. So the next one is going to talk about the Mars solar conjunction. I have a short introduction and then I will play the video. So basically, due to their orbits, Mars and Earth have to stop communicating with each other for about 2 weeks every 2 years. And, you know, it's a quiet period. And for the Perseverance team, it means that they can't send any new instructions to the rover. So I'm going to start the video now.
What happens when the sun blocks our signal? About every 2 years, Earth and Mars wind up on opposite sides of the sun. That's called solar conjunction. It's like being on either side of a huge bonfire. We can't see Mars, and our landers, rovers, and orbiters can't see us. If our spacecraft send back signals, charged particles from the sun could interfere, causing gaps in the data that reach us. That's not a big deal. If something's missing, it can always be resent later. But no way do we want to lose data when we send up commands. Receiving a partial command could confuse the spacecraft, putting them in grave danger. So mission controllers plan ahead by sending up simple to-do lists, including regular health checkups. Back home, this break in communications lets team members catch up on other work, or take a well-deserved vacation. Solar conjunction lasts just a few weeks, then it's back to the grindstone, on Earth and on Mars.
So earlier this year, pretty recently, Perseverance did collect a sample, and the collection of the sample, the mechanics of the rover, those worked great, but the sample that was pulled itself was not a viable sample. But I am happy to report that in early September, Perseverance did complete another sample. I have a video now that I'm going to show, which is going to explain how the rover pulls the samples. This is an animation, of course, but it's really informative. So I hope you guys enjoy this. I'm going to go ahead and start it now. So that is how all of the precious samples will be safely stowed on Mars for potential future pickup and even return to Earth by another mission. So I also mentioned that Perseverance has been exploring the Jezero crater for more than 217 Earth days. And so the rover has been hard at work to help determine the best rocks to sample to again look for those signs of ancient life. And I have another video for you, which is going to give you an update on the instrument that's being used for the exploration. And that instrument is called Sherlock.
NASA's Perseverance rover recently successfully sealed and stored the first 2 rock samples from Mars. One of the ways the rover analyzes the rocks it's sampling is with the Sherlock instrument and its camera, Watson. This detective team studies rock surfaces and building blocks of ancient life. To learn more, we are joined by Eva Scheller, who is part of the instrument science team. Eva, what is Sherlock and how does it help pick which rocks are worth sampling?
Sherlock is a really amazing instrument. It actually stands for the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. It has 2 components. One is a very good camera called Watson, and the other is Sherlock itself, which is actually an ultraviolet laser that we use to characterize the mineralogical compounds and organics on the Martian surface. And that tells us whether a particular rock is worth sampling or not.
So what has Sherlock told us about the rocks of Jezero crater so far?
Sherlock has made really amazing discoveries. We now know that these rocks derive from a volcanic environment and that there was liquid water there in Mars's past that formed salts that Sherlock has seen. And that actually has let us know that the samples we've just taken could have formed in an ancient habitable environment.
Now, looking to the future, what role will Sherlock play in the search for ancient life?
Sherlock is a very important instrument for 2 reasons. The first is that Sherlock is the only instrument that can directly detect organics, our building blocks for life, and we're always looking for organics in the samples we're taking. The second is that because Sherlock characterizes the chemical composition of the rock, that helps us understand whether any samples formed in an ancient habitable environment.
Ooh, sorry about that. We don't need to watch that video twice. So that is an update on, kind of the current status and, what has been happening with this mission. But now I want to talk about how NASA will explore Mars in the future. So NASA wants to send people to explore the red planet, but first they will send more robots. The sample return mission will continue the work that Perseverance started. The rover will stash the samples on Mars' surface, as we've already seen. And of course, the hope is that another mission can bring the rocks and the soil back to Earth. So NASA is studying new kinds of homes where astronauts could live in space. Scientists are studying how people in space could grow plants and food. They're watching what happens to astronauts on the International Space Station, or the ISS. And scientists are finding out how living in space affects humans long term. All of these studies and experience are helping NASA get ready to send people to Mars. This is a artist concept of the Mars sample return campaign. I just thought that it was a really beautiful image, and it shows the concept for a set of future robots who could work together to ferry back the samples. And I think it's a really great visual that shows how many working parts are going to be needed in order to complete this mission. So how are we going to get humans to Mars? Well, we're going to start with the moon. So I don't know if you've heard about the Artemis program, but this is humanity's return to the moon. So Artemis is in Greek mythology, Artemis is the twin sister of Apollo and also the goddess of the moon. It's the first step in the next era of human exploration, and it's the umbrella under which NASA's lunar plans fall as part of the broader Moon to Mars approach, which will send humans further into space and bring back to Earth new knowledge and new opportunities. So the Artemis program will land American astronauts on the moon by 2024. As a result of this program, NASA will establish a sustainable human presence on the moon by 2028. So that's right. This time we are staying, and we'll be able to do that because we'll be going to the moon in a way that we've never gone before. The Artemis program will land the first woman on the moon. It will land the first person of color on the moon, and it will use new technologies and systems to explore more of the lunar surface than ever before. There is collaboration with commercial and international partners, which will help establish the first long-term presence on the moon. And then we're going to use what we learn on and around the moon to take the next giant leap, which is Mars. So that's sending human explorers 250,000 miles to the moon and then 140 million miles to Mars. So before we get too far into where we're going, I want to talk a little bit about where we've been. So most of us are familiar with the Apollo mission and Neil Armstrong's infamous first steps on the moon. But Project Apollo was a national effort that had goals that went beyond landing Americans on the moon and returning them safely to Earth. So those included establishing the technology to meet other national interests in space, carrying out a program of scientific exploration of the moon, and developing human capability to work in the lunar environment. The Artemis program is going to build on the achievements of Apollo and more than 50 years of continued exploration. And it's going to honor the giants who conquered gravity and beckoned us to go and to seek. So why the moon? I mean, been there, done that, am I right? Well, the moon is actually a treasure trove of science. It holds opportunities for us to make discoveries about our own planet, our sun, and our solar system. We're going back to the moon not just to explore, but also for scientific discovery, economic benefits, and to inspire a new generation of explorers. Artemis will lay the foundation for long-term exploration in deep space. So with Artemis, NASA will reignite America's passion for discovery. The Artemis mission will enable a growing lunar economy by fueling new industries, supporting job growth, and furthering the demand for a skilled workforce and encouraging careers in STEM. And there is no question about it, humanity is going, and Artemis's success will change the world along with the way it will engage along the way it will engage and inspire new audiences, fostering the Artemis generation and lighting the way for all of us to continue building, studying, and preparing. So how are we going to do this? Well, we're going to build an Artemis base camp on the surface of the moon and the Gateway spaceship, which will be in lunar orbit. These elements will allow robots and astronauts to explore more and conduct more science than ever before. So the Orion spacecraft will carry astronauts from Earth to lunar orbit and back, and it's designed to meet the evolving needs of our nation's human exploration program for decades to come. There's the Space Launch System rocket. So this is the only rocket that can send Orion and the astronauts and cargo to the moon on a single mission. And upon launch, it will be the most powerful rocket in the world. The exploration ground systems will be the structures on the ground that are necessary to support launch and recovery of returning astronauts. There is also the Gateway. That will be the spaceship that's in lunar orbit, where the astronauts will transfer between Ryan and the lander on regular Artemis missions. And Gateway will remain in orbit for more than a decade, and it's going to provide a place to live and work and support long-term science and human exploration on and around the moon. The human landing system will be built by American companies, and these systems are the final mode of transportation that will take astronauts from lunar orbit to the surface and back to orbit. The Artemis base camp will give astronauts a place to live and work on the moon. And the concept includes a modern lunar cabin, a rover, and a mobile home. It's a pretty ambitious plan, right? Sounds futuristic, but it's happening now. And to get there, we're going to move forward to the moon in 2 phases. So phase 1 will include crewed and uncrewed test flights of the Space Launch System and Orion before sending astronauts to the Gateway by 2024. Before moving on to phase 2, the accomplishments in phase 1 will be the first demonstration of human flight beyond low Earth orbit since 1972, safe return of the crew, evaluation of system performances in deep space environments, and the first crew to the lunar surface via a human landing system from Gateway in lunar orbit. Phase 2 will establish sustainable missions on the surface of the moon by 2028. And as a reminder, we are in the last part of 2021, so this is not that far away. This is less than a decade. And in this phase, we'll continue to evolve the capabilities of the Space Launch System to launch cargo and astronauts aboard Orion to lunar orbit. And in this phase, we'll introduce the first flight and human presence on Gateway and lander elements. There'll be a demonstration execution of mission operations in deep space, and we'll build reliable programs to ensure success for later missions. Well, what are we going to look at while we are there? Well, there are broad-based lunar-based science themes that can be addressed with human robotic investigations on the moon, including the study of planetary processes, the impact history of the Earth-Moon system, a platform to study the universe and geospace, including Earth, a record of the ancient sun, and a platform for experimental science in the lunar environment. When NASA sends humans to the moon by 2024, they will land where no humans have ever been before, the lunar South Pole. This region, it's a good target for future human landing because robotically, it is the most thoroughly investigated region of the moon. We know that water is a critical resource for long-term exploration, and that's one of the main reasons that we plan to go to the South Pole. Water is a necessity for furthering human exploration because it could potentially be used for drinking, for cooling equipment, for breathing, and for making rocket fuel for missions that will go further into the solar system. And the experience that NASA gains on the moon, including using the lunar natural resources, will be used to help prepare the agency to send astronauts to Mars, of course. So what will we do next? Mars is calling. The moon is essentially a stepping stone. It's a place that we need to discover, a place that we need to go to discover how to live so that we can go even further. And by developing affordable and reusable systems on and around the moon, we'll test the technologies that we need to explore Mars by the 2030s. So Artemis, it's not a series of isolated missions, but it's part of a much larger mission to build a community on and around the moon capable of proving that we could reach and live on other worlds. And the Mars 2020 mission is also a part of this. And though the work is far from finished, the development of these deep space systems and a generation of inspired minds and innovative technologies have brought us closer to landing humans on the moon again than at any other time in our history since the Apollo program. And the sooner humanity goes back to the moon, the sooner humanity steps foot on Mars. I have one last video to share with you. This is an imagining of the beginning of the Artemis generation.
From the Kennedy Space Center in Florida at T-minus 3 hours and holding.
It is great to be in Florida today. The rocket is ready to go fly. The team is ready to go fly.
Not only for our expanded knowledge of the universe, but for the improvements you have contributed to on Earth. Have an excellent mission and Godspeed.
Crew ingress and work at this time.
Flight crew O2C, close and lock your visors and initiate O2 flow.
T-minus 10, 9, 8, 7, 6. All the engines up and burning. 2, 1, 0, and lift off.
So that is the end of today's presentation. I hope that you are inspired and curious to learn more about the things that were discussed today. And to do that, please visit the NASA website. There are pages and pages of information. There are lots of interactive features that you can explore, tons of free content, including some of the artwork that I shared today. And there's also a lot lot of activities that you can have access to. I hope that you will keep up on the discoveries that Perseverance and Ingenuity make, and that you'll follow the Moon to Mars initiative and the Artemis program. And who knows, maybe the next time I see you, we will be on another world. If you have any questions, we're happy to open up a Q&A or just open up a conversation. I'd love to hear, what you're interested in, or any stories you have, or if you want to tell me where you were when you watched the Mars rover land. And if there's any questions that I can't answer today, or that you can't find answers to on the NASA website, you can contact Denise, who can get a hold of me, or you can visit the Solar System Ambassador page. You can look me up and you can message me your questions, and I can do my best to talk to the contacts that I have through the Solar System Ambassador program to find those answers for you. At this time, I am going to stop the recording, but we will stay on for Q&A or for any comments.
Thank you, Jessica. That was wonderful. Can you hear me?